It's working. Thank you for confirmation. Somehow it is not showing to me. Okay, so it is working. Thank you for your patience. Now what we will be doing, we will be solving the questions which are important for your FA2 exam, right? Please let me know. Just a second. Let me refresh it once more. Yeah, thank you for your patience. Now we are in live. So what we will be doing here today, we will be discussing the questions which are which will be basically, first of all, your FA2 preparation, and the chapters that we are going to discuss are obviously the 4 chapters: alternating current, electromagnetic waves, ray optics and wave optics. We will be discussing MCQs from all these 4 chapters. Okay, MCQs from all the 4 chapters, and then if time permits we will try to solve some numericals from alternating current and see some important questions from the chapter ray optics as well. Okay, if you have any other chapters in your FA2 exam, please let me know. Also let me know when is your physics exam in your FA2. Okay, so if it is already completed, then how was it? Is the question paper was difficult or easy? Please let me know in the chat as well, right? So let's start with the MCQ first. And anyway, even if your FA2 is over, there is no harm in practicing more, especially MCQs, because most of you face difficulties in answering MCQs. So that's why MCQs are very important in my opinion. So you have to keep practicing MCQs as much as possible. Let's see first question. Different devices connected to an AC source are listed in the first column, and different phase relations of the electric current with the voltage are listed in the second column. Choose the correct match. So resistor, inductor, capacitor, and lags behind the voltage by pi by 2 is in phase with the voltage, leads the voltage by pi by 2. Okay. Okay, Karthik is saying tomorrow is the exam. Okay, Karthik, then you should not leave the stream. All the important questions I will be discussing in today's lecture. Okay, and if your exam, if someone else's exams are over, please let me know as well. Okay, now so let's see, resistor. What is the property of resistor? In resistor, if the only resistor is connected to an AC source, the current is always in phase with the voltage, right? So for resistor, current is always in phase with the voltage. In case of inductor, current lags behind. So for inductor, current lags behind, and for capacitor, current leads the voltage. Okay, so correct relationship will be 1 is matching with Q, 1 is matching with Q, 2 is matching with P, and 3 is matching with R. So 1 is matching with P, 2 is matching with Q, and 3 is matching with R. So option A is the correct match, right? How many of you? Good evening, Rukmini. Okay, you have on Monday, then all the best. Obviously, if you watch this lecture, then definitely it will help you a lot in your FA2 exam. That preparation, our dream is to help you as much as possible, and obviously it is on your interest that we are doing FA2 again once more. Okay, we have discussed a lot of FA2 related stuffs, then again we are discussing once more another FA2 lecture. Yesterday Ankit sir took, today I will be taking, and tomorrow will be your chemistry lecture by Saini ma'am, so don't miss out on that as well. So now question number 2. The resonance phenomenon is exhibited by a circuit only if it is following components are present. So what is the question? Resonance phenomena is observed only when any one of them are present. Which are them? L and R, R and C, L and C, none of the above. So which is the answer? Good evening, Prakash. So 2C, yes, L and C are mandatory. L and C are mandatory to have resonance phenomena. Okay, so L and C are mandatory to have your just a second, guys, I am having a call. Please let me give me 2 seconds. Sorry guys, there was some interruption during I didn't wanted to miss this call. Okay, good evening. Now next question, the relationship between peak value Im of current and RMS current is. So what is the relationship between peak current and RMS current? Let's answer this quickly. Quickly guys, easy question. So the relationship between peak value of current Im and RMS current is always given by IRMS equals to peak value divided by √2. Remember this. Similarly, VRMS equals to Vm by √2. Sometimes the same question they will ask. You have to remember Im equals to √2 IRMS. This option can also possibly come. So this is also a variation of the same question. Okay, and Vm equals to √2 VRMS. So which one is the correct answer? Obviously option B. Yes, option B is correct answer. Right, now next, an ideal step up transformer. Step up and step down. Let us understand these two terms, step up and step down. Step up means it output voltage is more, so voltage increases, and to increase voltage we compromise on current, so current decreases. Okay, these are the two things you have to remember. Step up means voltage is increased, current is decreased. Step down means voltage is decreased and current increases. So if you remember these two easy facts, then all problems you can solve. There are some relationship related to number of turns, etc., but we do not want to go into that part, at least for boards. Based on that we will get questions in KCET. Remember, power in both cases, power is constant, power is same, and the condition for that is for ideal transformer. and for your board exam every transformer will be ideal transformer. Okay, an ideal step up transformer decreases current, it decreases current, it increases voltage, it decreases current. Yes, correct answer option A. Now next, question number 5. In a transformer, the windings of the primary and secondary coils are wound on one over the other to reduce the energy loss due to. So in transformer generally there are two setups. One setup is simple where we have a box kind of setup. Okay, this side is called primary where we are applying the voltage, and this side is called secondary where we collect the voltage through a resistor. Okay, this is called secondary, this is called primary. This is standard setup, but there is some problem with this setup, so we sometimes use another setup where, okay, primary and secondary, they are connected in the same way, through the same core. Okay, so this is our secondary, this is our primary. Okay, and this is done to reduce one of the problems that is happening inside the transformer. What is the problem? Is it flux leakage? Is it resistance of the windings? Is it eddy currents, or is it hysteresis? There are 4 types of losses in a transformer. Which loss is being managed over here? So this is a flux leakage. So when we combine one coil over another, all the flux which is coming out of the primary should go through the secondary, and transformer works on the principle of mutual inductance. So that means you cannot have any flux that is going outside. That means you have a perfect flux linked coil. So this is one of the way to reduce the flux leakage, and this is why they are winding one over another. Next, the frequency of X-rays, gamma rays and UV rays are A, B and C respectively. Then which of the following relationship is correct? So if you remember the electromagnetic table, first comes gamma ray, next in the line is X-ray, next is UV, then we have visible, then infrared, then microwave, and lastly radio waves. Now if you go from here, the frequency is high. The frequency is high and here it is low. This direction it goes, frequency is going from high to low, and wavelength here it is low and this is high. Okay, so in case of wavelength, when you are traveling from gamma ray to X-ray, the wavelength decreases. So when you are traveling from radio to gamma ray, wavelength increases and frequency decreases when you are going in this direction. Okay, so remember this. Now here it is mentioned that gamma ray X-ray is given by A, gamma ray is given by B, and UV rays is given by C. Okay, so which one has highest frequency? Highest frequency is gamma rays, so B should be greater than that of A, and next in the line is X-ray, so X-ray should be greater than C. So B greater than A greater than C. So correct answer is option B. Yes, correct answer is option B. Correct, Rukmini. Next question is speed of light according to Maxwell's equation is given by. From Maxwell's equation we actually calculate speed of light, and that turns out to be exact match for the speed of light measured through experiment, and that's why we can say that light is an electromagnetic wave. Okay, because this theory corresponds to electromagnetic wave theory, and because it is matching with the speed of light in experimental measurement, we say that light is an electromagnetic wave. Okay, so which one is the correct answer for this question? 7 is C. Yes, remember 1 by mu naught epsilon naught is the speed of light of vacuum. Speed of light in vacuum. Remember, this is speed of light in vacuum. For any other medium, it can change. It is mu into epsilon, and mu epsilon can be swapped. So refractive index, in case of refractive index, the same equation can be calculated again, but we will not do that. So remember that speed of light is 1 by mu naught epsilon naught. Okay. The angle between electric field and magnetic field in an electromagnetic wave. The angle between electric field and magnetic field in an electromagnetic wave is. So, angle between electric field and magnetic field in an electromagnetic wave is 90 degrees, 45 degrees, 30 degrees, 0 degrees. Suppose this is the direction of propagation of the wave. So, what is this angle? This is the good evening, Nagraj. Hi. Sorry, I missed your good evening comment. So, Nagraj is saying 8A. Nagraj, when is your FA2 exam? Let me know. So, yes. So, here it is a three-dimensional diagram. So, E is along this axis, B is along this axis, and the wave is propagating in this direction. So, remember that E, B and the direction of propagation, they are always mutually perpendicular. These three things are always mutually perpendicular. Mutually perpendicular means always it will be 90 degrees. E with direction of wave, B with direction of wave, and E and B mutually, every three quantities, three vectors will always be mutually perpendicular. So, answer is 90 degrees. Yes, Rukmini also answered it correct. 90, I don't understand, Nagraj, what you are trying to say. When is your, I just asked when is your FA2 exam? So, your FA2 exam is over or it is going to happen. When is it? According to the generalized Ampere-Maxwell law, B dot dl, which one is the correct statement? Okay, this is a previous year question. Last 2 years back, I think this question came. B dot dl is which of them is correct? Mu naught IC plus epsilon naught mu naught d phi E d by dt, mu naught into IC, epsilon naught into d phi E by dt, epsilon naught mu naught d phi E by dt. Finished already in 15th. Okay, how was it? Let me know, tell me, how was your exam? So, yes. Now, what about this question? Question number 9. Question number 9, remember that from Maxwell's law, from Ampere's law, it was B dot dl, okay, was given by mu naught I. Now, this current, when Maxwell came into picture, he called this current as conduction current, and he said that conduction current is not alone. There is a brother of his of conduction current, which we sometimes ignore, which is actually displacement current, and he gave the expression for displacement current as well. He said displacement current is epsilon naught d phi E by dt. So, if you put these all things together, then you will get this as the expression for B dot dl. So, correct answer is this. Remember, this is also sometimes comes the expression for displacement current. This is also possible in your MCQ exam. So, in any exam, a pre-board, FA2, board exam, this is also important. Remember, epsilon naught d phi by dt is the displacement current, whereas you have to add a mu naught and mu naught IC to get the total current, that is B dot dl. Which of the following is absorbed by ozone layer? X-ray, gamma ray, UV ray, all of the above. Yes, Nagraj, 9A, Rukmini and both of you have answered correctly. Now answer this question. Which of the following is absorbed by ozone layer? X-ray, gamma ray, UV ray. Okay. So, the sorry, yes, 10C. Actually, no. All high energy radiation is absorbed by ozone layer. Ozone layer absorbs X-ray, ozone layer absorbs gamma ray, ozone layer absorbs UV ray. Okay, now in sunlight, X-ray and gamma ray are less present in less amount. UV ray is most amount of ray is UV ray. Harmful rays, in terms of harmful rays, UV rays are the most harmful. So UV rays are also getting absorbed along with gamma ray and X-ray. Any high energy rays are basically absorbed in the ozone layer. So all of the above is answer, not UV ray only. Ozone layer absorbs everything. We know that what happens, you know, when oxygen is combined with another atomic oxygen, okay, they actually form ozone. Okay, and they continuously, this is not very stable, so they continuously break into O2 plus O. Now as soon as any high energy radiation falls on them, okay, they again recombine to construct back the ozone. Okay, I think you may have studied it in your chemistry. When I was a student, it was there in our chemistry. I'm not sure it is still there, the importance of ozone layer. Okay, so ozone basically decomposes into oxygen and atomic oxygen, and when some high energy struck to it, it again recombines into ozone, and this high energy can be X-ray, it can be gamma ray, it can be UV ray as well. Okay. Okay, now let's move on to the next question. The angle of minimum deviation of a prism depends on refractive index of the material of the prism, number 1. Number 2, refractive index of the surrounding medium. Number 3, refracting angle of the prism. So refractive index of the material of the prism, say N, refractive index of the surrounding, say Ns, and angle of the prism is A. On which factor the angle of minimum deviation depends? Let's see who can answer. Only option 1, only option 2, only option 3, all 1, 2 and 3. So for that, again we will use that refractive index of the medium with respect to surrounding is given by sine A plus delta m by 2 divided by sine A by 2. So from here we can say that sine A plus delta m by 2 equals to n by ns sine A by 2. This is the Snell's law, right? Now if you want to calculate delta m from this equation, you need to know the value of A, you need to know the refractive index of the material of the prism, also you need to know the refractive index of the surroundings of the prism. Remember, surroundings, even though it is not directly present in the formula, generally the formula that we write, because in that case we assume the surrounding is air. If it is not air, then you have to consider the refractive index of the surrounding as well. Okay, so correct answer is yes, option D. Option D, all of the above, 1, 2 and 3 is correct answer. Now next question. Total internal reflection is possible when light is traveling from air to water, water to air, air to glass, all of the above. Now total internal reflection is possible when light is traveling from denser to rarer medium. It is not possible in the opposite sense. Okay, so light must travel from denser to rarer medium. So which one between water, glass and air is denser? Obviously glass is the densest, water is the second densest. But when light is traveling from air to glass, light is traveling from rarer to denser medium, not denser to rarer. Okay, so definitely this will not give you any total internal reflection. Again, air to water, another rarer to denser medium, so it will also not give you any total internal reflection. So total internal reflection is only given by water to air, so all of the above is also incorrect. So correct answer is water to air, because from water to air, light traveling from denser to rarer medium, so definitely it is the correct answer. Yes, it's me extreme. Hello sir, Firat, all thank you so much. I had not studied physics, but after watching your gunshot video of AC, EMW, ray optics and wave optics, I can score more than 31 marks. All MCQs were the same. Congratulations, it's me Extreme. So if you follow our channel, don't forget to follow our channel, subscribe to our channel, and share this video to your friends, those who are also not studying, right? Share this so that they can also join in and study with us. Okay, we are more than happy to help everyone, right? Image of the real object formed by a simple microscope when the object is placed at a distance less than the one focal length is. Real inverted, so image of a real object formed by a simple microscope. Simple microscope means what? Simple microscope means it's a convex lens, okay, and the object is placed at a distance less than the focal length. Less than the focal length, that is how our simple microscope works. Simple microscope means the spyglass used by Sherlock Holmes, those who are fascinated with spy stories, spy movies, okay, this, or not spy, I will say, detective stories, detective novels. Those who read, they know that every detective has a spyglass. He uses it to find who is the culprit behind a murder, right? So here the spyglass or the simple microscope is basically a convex lens where we are using it at a distance less than the focal length. Less than focal length means it will give you a virtual enlarged, okay, virtual and enlarged image, and that's how you can see the object in a larger form, and you can see if there are some hidden fingerprints are there or some hidden information is there. So that's how simple microscope works. And if you are using it in the biology lab, we can see some small objects, even very smaller, through the simple microscope. Same principle, only thing is the design is slightly different. Okay, so the image formed will be virtual, erect and magnified. Virtual, erect and magnified. Yes, Rukmini is correct. My friends also confident that they will score more than 30 marks. All thanks to you, sir. Thank you, it's me. So bring more friends to our channel. We are growing, right? We want to grow a little bit faster at this rate, right? So that's why we are obviously trying to help you as much as possible. Share it with your friends, those who are not, subscribe to our channel so that we can have a discussion together, right? The lens nearest to the object in a microscope is called the lens nearest to the object in a microscope. Nearest to the object means objective lens, right? Nearest to the object is objective lens, nearest to the eye is eyepiece. Okay, the names are very obvious. Same name goes for a telescope as well, objective and eyepiece, and for microscope as well, objective and eyepiece. So the objective lens is the lens which is the lens nearest to the object. So objective lens. Okay, 14b. Yes. Now next, one problem with the reflecting telescope is that the objective mirror focuses light. Okay, one problem with the reflecting telescope is that the objective mirror focuses light inside the lens, outside the telescope tube, inside the telescope tube, all of the above. Now obviously it is a reflecting telescope. Reflecting telescope don't have any lenses, so it basically only uses mirrors. So definitely inside the lens cannot be correct. Inside the lens cannot be correct, so it has to be something else. So all of the above obviously also not correct. So two options already, you are playing KVC and you already got 50-50 option, right? So two of them are incorrect. So which one will be correct? Rukmini is saying 15B, outside the telescope tube. Now if you are using a reflecting telescope, this is your telescope tube, and if the it is forming outside the telescope tube, you can easily put a screen over here and you can have the image. So if it is forming outside the tube, we would not have any problem. We can easily place some screen at that point and we can observe it. That is not an issue. But if it is inside the telescope tube, imagine that you are using a telescope tube, okay, you are using a telescope tube and this is your opening from where light is falling, and the final image is forming over here. Is there any way for you to observe it directly? So if it is a reflecting telescope, this side is already closed, okay, this side is closed because you have the mirror over here. So your final image is forming inside the tube, and because the final image is forming inside the tube, you will not have any direct way to observe it. Okay, Cassegrain overcome this using a particular technique. What he did, he used a small hole behind the lens mirror. So he, instead of using a continuous mirror, he used a pieces of mirror like this, and in the center there was a hole, and when the ray of light is falling on the mirror, after reflection he uses another convex mirror. Okay, convex mirror usually forms a virtual image, but in this particular case, because the image itself is virtual, so it will converge it like this, and you will observe it through your eyepiece over here. Okay, but if it is only a concave mirror, you will not be able to observe it clearly. Okay, modern telescopes that is used by super laboratories and institutes, they do what they do, they, instead of putting a convex mirror, they directly put a sensor. Okay, they put a sensor over here, like camera sensor. Similarly, they put a sensor over here, which is lightly attached to this using some simple instrument. Okay, now everything, we know the focal length. Okay, focal length of a mirror is fixed, so we can easily put that sensor in the focal length. Even the sensor can be adjusted as well, and that's why if you see modern telescopes, they will always have this kind of diagram. Okay, radio telescopes as well as any optical telescope, they will always have a sensor located like this, and that sensor can detect the image, and that will be processed directly to the computer. They will process it and send it directly to the computer, and you can get the image straight away. Okay. Rukmini is saying, can we please do ray optics problems? Definitely, after 5 more MCQs, we will be doing ray optics MCQ, that is ray optics problems. That is in my agenda directly. Obviously, we will solve. Don't worry. Let me finish the MCQs first. Okay. So this is why we will say that light rays are forming inside the telescope tube is a problem, not outside. Outside would be happy. We would be happy if it is forming outside, but inside the telescope tube is a problem. Okay, after the MCQs, 20 MCQs are there, we are already at 16th. Okay, so definitely we will be solving the ray optics numericals. Don't worry. If unpolarized light of intensity I0 passed through a Polaroid, then the intensity of emergent light is unpolarized light passing through a Polaroid. What will be the intensity? Intensity for a Polaroid, it drops to half when it is unpolarized, and when it is passing through a Polaroid, okay, the intensity drops to half. Intensity of the emergent light drops to half. So it is I0 by 2. Intensity is I0 by 2. Clear? Next, the phenomena of bending of light at the corners of an obstacle is called. Phenomena of bending of light at the obstacle, 16 DS, correct. Phenomena of bending of light at an obstacle, this is also easy. So when light traveling along some sharp edge, light do bend, and this is called as Nagaraj also said 16D. So what is the bending of light called? Bending of light means normally when you are kid, we have studied that light always travel in a straight line, but at class 12th we are learning that light do not always travel in straight line, but it can bend around edges as well, and that is called diffraction. That is called diffraction. This is called diffraction. Diffraction is easily observable for sounds, but we do not pay attention for that. So for example, if someone is shouting outside your home, you are still able to hear that voice even though they are not direct in line with you, because light can diffract and it can go in different direction. Sound can diffract and it can go different direction. For sound, the wavelength is very high in the range of meters, whereas for light it is in the nanometer range. So it is very difficult for us to observe diffraction in normal day-to-day life. Next, According to Huygens principle, the speed of the secondary wavelets is twice that of the wave, 0, same as the wave, infinite. Yes, Rukmini said 17D, correct answer. Now what about this? According to Huygens principle, the speed of the secondary wavelet is twice the wave, 0, same as the wave, infinite. It is same as the wave. Okay, secondary wavelets, they always move with the same speed as the original wave. That is the Huygens principle. So obviously same as the wave. Next, when a point source of light placed at the principal focus of a thin convex lens, the shape of the emergent wavefront is. When yes, 18 was C. Now 19. When a point source of light is placed at the principal focus of a thin convex lens, the shape of the emergent wavefront is. So here we have a convex lens and a point source is placed at the focus. Point source is placed at the focus. So what is the emergent wavefront? First of all, when you place, first of all try to draw the ray diagram. Especially these kind of questions are very common nowadays. You can expect one such question. Okay, so first try to draw the ray diagram. Okay, if they are parallel to each other, then the emergent wavefront is basically plane. If they are converging somewhere, then the emergent wavefront will be spherical but curved like this. If they are diverging from somewhere, okay, if they are diverging from somewhere, then it will be spherical again, but it will be the spheres curves will be outside. Okay, and if they are parallel, it will be plane along the parallel lines. Okay, perpendicular to everything. So plane wavefront is the correct answer. Option C is correct. 19, no, not 19D, Nagraj, not 19A as well. Okay, because the rays are not converging. Okay, rays are becoming parallel. Rays are becoming parallel means the wavefront will be also parallel. If it is converging or diverging, then it will be spherical. If it is converging or diverging, it will be spherical. And cylindrical happens when the source is extended. If the source is extended, for example, if you take a extended source of light, for example a tube light. Okay, if you take a tube light, okay, in that case the wavefronts are cylindrical in nature. It can be considered as a it's expanding like this, multiple convergence of multiple spherical wavefronts, and you will get a cylindrical shape. Cylindrical is only for extended sources. For point sources, it will be either plane or it will be parallel. Okay, plane wavefront here. Now next, last MCQ, the shape of the wavefront for light coming from a distant star. Shape of light coming from a distant star. Now how do we represent light coming from a distant star? Distant star always gives us parallel lights, right? Parallel lights. So distant star always gives us parallel light because they are so far away. Okay, they are, after traveling so much, they have become almost parallel. So that means the wavefront will be again plane. It will again be plane wavefront. Okay, so distant stars also gives us plane wavefront. Yes, object is placed at infinity. If the object is placed at infinity, then wavefront will be parallel. Now for a convex lens, if same question is asked that a ray of light from a distant star falls on a convex lens, then this question came in KCET last year. Okay, then what will happen? Then the ray will be converging at the focus and you will get a wavefront like this. That was a diagram based question in KCET. So the question is very simple, but you have to understand that it will be inward curves. Curves will be inward. So this will always be, if they are converging at some point, this will act as the center of the sphere. Okay, so remember, if they are converging or diverging based on how they are situated, so that will behave as the center. If this is the center, then it will be curved like this. If this is the center, this will be curved like this. Try to draw the ray diagram. If you draw the ray diagram, the problem becomes simple. Okay, now let me go to the ray optics numerical question. Okay. Yes. So this question is from ray optics. An object of height 1 millimeter is kept perpendicular to the axis of a thin convex lens of power plus 10D. And remember that in pre-board exam, in your FA2 exam, examiners like the questions which are given, focal length is given in terms of power. Okay, the distance between the object and the lens is 15 centimeter. Find the position and height of the image formed. Remember that whenever power based questions are given, power is plus 10. That means when you are calculating the focal length, don't just simply put 1 by f. Here power, when power is given, focal length is calculated in meters. To convert in centimeters, you have to use this 100 by f. This is a shortcut. You can directly calculate the focal length in centimeters. Okay, we know power is 1 by f, but here focal length is given in meters. Okay, so whenever you are calculating focal length back from power, always use 100 by p so that you can calculate the focal length directly. Similarly, focal length is given, you want to convert it into power, again 100 by f. Okay, 100 by p, 100 by f, directly you can convert the power. Power and focal lengths can be converted from centimeter to meter. Don't need to convert again and then do the next step. Now again here u is given as, so whenever any mirror or lens based questions are given, u is always negative. Focal length here it is a given positive itself, because power is positive means focal length will also be positive. Okay, now you have to calculate what is v. Now convex length, so we will use lens equation 1 by v minus 1 by u equals to 1 by f. Okay, so what is 1 by v? 1 by v we don't know, so it will be equals to 1 by f plus 1 by u. Always solve smartest way possible. Okay, always solve in a smartest way possible so that you don't have to put the values from the beginning and finally you make some small mistake and your answer is completely wrong. Don't do that. So u is given here minus 15, f is given here as plus 10 divided by minus 15 plus 10, that is minus 150 divided by minus 5. So minus minus cancels, you get 30 centimeter. Okay, so the position of the image is 30 centimeter. What about the height? So this problem is not over yet, you have to find the height as well. So height of the image, here initial height of the object is given 1 millimeter. So height of the image is given by magnification times height of the object. So what is magnification? Magnification is minus v by u. Okay, sorry, for lens there is no negative sign to start with, for mirror there is a negative sign. Okay, so here we have to put 30 divided by minus 15 into 1 millimeter, so that will be minus 2 millimeter. Now what is the meaning of this minus? This minus represents that image is inverted. The minus sign, the negative sign represents image is inverted. Okay, if you have any doubt in this, if the same 19th question is asked for concave lens, what would be the answer, sir? Okay, so let me show you the so suppose same 19th question where it says the concave lens. So here we have a point source, okay, and the ray of light is falling on the concave lens. Okay, so what will happen in this case? So concave lens, if it is it will start diverging, right? It will diverge. Concave lens does not have this property, okay, that parallel, it will not become parallel. Okay, it will simply diverge it. Okay, if parallel ray falls on it, then it can be a tricky question. So in normal case it will be just diverging, so you have to track them back, and the wavefront will be like this. It will be spherical. Okay, for concave lens it will be spherical. And if they ask you for concave lens, if they ask that if parallel ray falls on the concave lens, then after it falls on the concave lens, it actually diverges, but if you track them back, it always starts from the focus. Okay, so for concave lens this question is more meaningful. Okay, you will know the location, so the after coming out it will be again spherical. For concave lens it will be always spherical, curving outward. Okay, clear? Right. Now one more question I will be solving, 30 centimeter 2 millimeter. One more question I will be solving. Excuse me. A double convex lens made of glass of refractive index 1.5 has a radii of curvature of 20 centimeter and 15 centimeter is immersed in water of refractive index 1.33. Calculate the change in the focal length of the lens. Okay, so double convex lens, one side has a radius of curvature 20, another side has a radius of curvature is 15. Okay, so and the refractive index of the medium is 1.5. So now they are asking you what will be the change in focal length. How to calculate change in focal length? First of all, to do that you have to calculate the first focal length. So when it is in air, so let's say this is in air, and obviously what formula we will be using? We will be using the lens maker's formula. Okay, so lens maker's formula is given by n minus 1 by r1 minus 1 by r2. Okay, so what is r1 over here? R1 is 20. What about r2? So if you see that r2 is in the opposite direction. Opposite direction means r2 will be minus. R2 will be minus. So now we have to put the values. Refractive index is 1.5 minus 1. So this will be 1 by 20 minus 1 by minus 15. So we get 0.5 into 20 into 15 is 300. Okay, and we get here obviously the sign becomes plus now because minus minus plus. So we get 15 plus 20. Okay, this is the easiest way. I don't want to do exact LCM. 300 into 35. Okay, 300 into 35, so it will be 7 and 60. So it will be 120 divided by 7. 120 divided by 7 is the initial focal length. Now what will be the final focal length? That we have to calculate. To calculate the final focal length, when it is immersed in water, when it's immersed in water, the focal length, the formula will remain same. Only thing that you have to do is in this n you have to divide it by the refractive index of water. Okay, and it will be 1 by r1 minus 1 by r2. Now if you see that 1 by r1 minus 1 by r2 we have already calculated. Okay, this was 1 by fa, this is fa. Okay, so if you have already calculated 1 by r1 minus 1 by r2, that turns out to be this value. So only thing we need to calculate is this one. So it will be 1.5 by 1.33 minus 1 into 35 by 300, right? Now 1 by 5, 1.5 by 1.33 can be written as 3 by 2 divided by 4 by 3. Okay, 1.33 is 4 by 3, 1.5 is 3 by 2 minus 1. So that can be converted into 9 by 8 minus 1, or it will be 1 by 8. So if you calculate everything without using calculator, you will get this value as 1 by 8, which is much better than using a calculator. So 35 by 300. Okay, so it will be cancelled. 7 by 60. So we get this as F water will be 60 into 8 is 48, 480 divided by 7. So this is the final focal length. This is the initial focal length, this is the final focal length. What is the change in focal length? Change in focal length is final minus initial, right? So that will be 480 by 7 minus 120 by 7. That would be 360 by 7, which almost equals to 51 centimeter. Approximately 51 centimeter is change in the focal length, or you can take this as 50 as well, but 36 is 5 sevens are 35, and there is one more 10, so 51. If you use the calculator, 51. Art gallery is saying tests are over. So how was your test, art gallery? How was your physics test? And how was the questions? Okay, let me solve one more question. This one is from your model question paper. Double convex lenses are, let me know how was your exam. If your exams are over, how is your physics test? Let me know. Double convex lenses are to be manufactured from a glass of refractive index 1.55 with both faces of the same radius of curvature. Find the radius of curvature required if the focal length is to be 20 centimeter. Also find the new focal length of the lens if it is immersed in the water of refractive index 1.33. So second part I will not be solving. I will only solving the first part. Second part you have to solve it yourself. I have already shown you once this method. Okay, so to calculate the second focal length, only thing you need to consider, and most cases, 99% cases, you will be given the combination of glass and water. And if it is given 1.5 for glass, glass can have refractive index ranging from 1.5 to 1.65. So if it is 1.5, you can use this method. If it is not 1.5, then there is no other way, you have to use the calculator. Okay, so here as example, here it is given 1.55, so you have to use calculator, there is no other way. Okay. Okay, so here we are saying that we are using a double convex lens of same radius of curvature. That means this will be minus r and this side will be plus r. This much you have to understand. Okay, so anything on the right hand side along the positive x-axis is positive, anything along the negative x-axis has to be negative. Now this surface comes first and its radius of curvature on the right hand side, so this radius of curvature is positive. This is the second, so if the ray is traveling here, it is falling on this surface first, and its radius of curvature is positive. This surface comes next, so this surface comes next means this will have a negative radius of curvature. That's why we take this as negative value. Okay, now lens maker's equation, 1 by f equals to, in air, n minus 1 by r minus 1 by minus r. For convex lens, it is always easier to remember that the focal length will be positive. There is no cancellation. Okay, do not cancel them. Required focal length given here is 20 centimeters. So FA is given here. So 1 by 20 is given, and n is given as 1.55 minus 1, and if you calculate this, you will get 2 by r. Okay, 1 by r plus minus minus plus, so plus 1 by r, so it will be 2 by r. So from here we can calculate r equals to 1.55 minus 1 into 2 divided into 20. Okay, cross multiply, so this will go here, this will this r will come here. Okay, so now what we will be doing, r equals to 0.55 minus 1 is 0.55 minus 1 is 1.55 minus 1, 0.55 into 2 into 20. So 1.1 into 20, this is 1.1, so or this is equals to 22. So radius of curvature will be 22. Now if you take this same lens and if you put it into the water, then if water, I am giving you the hint, I am not solving it. So n by n water minus 1 into 2 by r. So this is the shortcut. Okay, 2 by r you can directly write, r value you have calculated to be 22. Now put the value of n, put the value of in water, simplify it. Okay, do some videos on how to solve physics KCET in short method please sir, art gallery is saying. Okay, I will definitely, as KCET is approaching, once the KCET starts approach, we will definitely make some videos on how to apply shortcuts in KCET. Right now our slide focus more on towards boards, right? We are doing weekend videos. In weekend you will get some more questions on KCET. And remember one thing, in KCET you do not need to learn too many shortcut tricks. Too many shortcut tricks are required for solving quickly in JEE. Shortcut tricks are good for NEET as well. But for KCET, even if you learn only few basic shortcuts, that is sufficient. Okay. So, and we will be doing some basic shortcuts in KCET as well soon after. So if you solve it, you will get this as 66.5. KCET basic shortcuts we will be doing, and it is being done throughout our lecture. If you watch any of our lecture, we try to give you as much as shortcuts. Only one shortcut for KCET which I recommend is to learn how to calculate without using calculator. Okay, if you learn how to calculate without using calculator, and that is fast, that is a best shortcut for KCET, right? And try to watch our videos. We all do that, tricks and tips. If there are some tricks available, definitely we will try to give you. But in KCET, not too many shortcut tricks comes. Okay, few cases there are. For example, in capacitors there are few questions which might be solved. For example, if you insert some blocks inside a capacitor, I did one video on that as well. But we will try to make some shortcut tricks and tips in KCET related physics questions as well. Don't worry. Okay, so I have to close this session now. If you have any more questions, please try to post that in the chat. Okay, otherwise thank you for watching, and if you want me to solve more questions, please let me know that in the comment section below as well, right? Thank you.